Hi guys, this is Chris from CSB Electronics, and here we have the Fire Commander burn-in test bench. Basically this test bench here is used to test each and every module that we build, so that we ensure that when the customer receives it, it's working in as it should be. Also, since this is a burn-in test, we are operating the module at much higher parameters than they are recommended in the manual, so that should something start to fail, we see it immediately. Well, let's start with the setup. Basically, we have an ECU simulator here, which basically simulates an ECU. It's providing pulses which are varying from 900 RPM till 12,000 RPM every 20 seconds, I think. It's something like that. We have 4 coils here, coil-on plugs. These are 0.5 ohms internal resistance off-state, and each one of them has 5.3 millihenries of inductance. We have a junction box here that all the wiring goes into this junction box, and we have various meters. We have an ammeter, a temperature meter, which is connected, which has the thermocouple connected to the transistors here, so that we can monitor the temperature, and we have an oscilloscope so that we can monitor the delays between the inputs and the outputs. The unique feature about this module is that it's basically fully isolated, which means that there is no electrical path between the outputs and the inputs which are on the ECU side. This thing offers superior protection, because when the coil is shutting off, it generates, due to leakage inductance, it generates stray voltages of up to 400-500 volts DC, which if something bad happens inside the transistors and they all go short or so, these little voltages might find their way inside the ECU signal paths, and thanks to this module this is not the case. So if the transistors for some reason short out, there is no way that these voltages can find their way into the inputs of the module. Okay, so let's start the setup. Okay, so what we're seeing here, we are pulsing the module. In fact, one can see the coils. We are running the coils, and we are monitoring the temperature and the current. In fact, current is around 34 amps, and temperature is rising because, you know, we are given the module is quite loaded. Also, we can see the delays on the scope. Basically, this is the pulse of the scope, okay, of the ECU, and this is the turn on delay of the module. So what we can see here, it is around 1.8 microseconds, so it's fairly fast. Okay, so here we have this is basically the turn off of the ECU, and this is the turn off of the module, and we can see that it has around 10 microseconds turn off delay, which is extremely fast for an engine. I mean, all ECUs operate in milliseconds and not microseconds, so it's fairly fast. In fact, we are seeing that temperature is rising, but it's setting at around basically 63-64 degrees, because we've installed a very large heatsink having 0.2 degrees per watt. And the reason for installing this kind of heatsink is because basically we are running the module above its absolute maximum recommended parameters, but we have to be sure that everything is working fine, so we have to do this. Basically, that's just about it. Dwell times are also higher than the recommended, so the higher the dwell times, basically the more load it puts on the module, so that we will be sure that everything is working as intended. So I hope that this module, this video help you to understand our product better, and should you have any questions, don't hesitate to contact us. Thank you.